We move on to another aspect of trigonometry, and this is called application of trigonometry to an aspect in mathematics called angles of elevation and depression. If this is your first time of visiting this channel and you find these videos helpful, kindly subscribe. So I want to quickly say every aspect of elevation and depression entails drawing right triangles. So if you look at what we have, the angle of elevation of the top X of a vertical pole from a point P on the level ground, we begin to see that this angle, we begin to argue. This angle belongs to, does it belong to top X or to a point P? If you look at this top X, they say angle of elevation of top X. But here they say angle from point P. In elevation and depression and also topics such as bearing, it is from that determines where the angle is. So this angle is at point P. They said from point P, it is not off. Even though they said the angle of elevation of top X, that doesn't make this angle be at X. So it has P. Let's take note of that. So let's sketch a diagram, a right triangle. Now, since they said the angle of elevation of the top X of a vertical pole, so this vertical line, we call it a pole. So here we have point X here. And they said from a point P on level ground. So P will be here. This is where the viewer is from the viewer always. The angle is always with the eye of the viewer. This is the eye of the viewer. When the viewer has not viewed anything, the eye level is at this place. But immediately the viewer has lifted up the eyelid to be able to view something higher than his eye level, then the angle is attached to the eye like this at this place. So, and since the angle is given to be 60 degrees, we indicate it 60 degrees. And they said the distance from the foot of the pole, this is foot of the pole. The distance from the foot, the distance from P, the distance from P to the foot of the pole. So there is P here, so sorry, there is P here, the distance from P to the foot of the pole. So that means this place is a 55 meter. And we ask, find the height of the pole. We want to find the height of the pole, this H. So if you look at this, we still go back to our acronym, SOHCAHTOA. SOHCAHTOA. Here we have the angle here. The side opposite to the angle is what we call opposite, and the last side or the third side of a triangle is adjacent, while the longest one facing the right angle is hypotenuse. So that one is already clear, but it is opposite and adjacent that can interchange their position depending on which one is opposite to the angle. The opposite to the angle will be tagged opposite, while the last one will be adjacent. So that means here we are dealing with opposite and adjacent, which is combined by tangent. Tan take the ratio of opposite and adjacent. So we say tan of the angle, tan 60 degree equals to opposite, in this case is H, adjacent is 55. Now that they has that we must not use tables or calculator. So to find tan 60, we use, every candidate should try and memorize this special triangle. We have 60 degree here, we have 30 degree here. So we have 2 here, here is 3, and here is 1. There's a way this ratio of size are derived. So when you have something like this, just take note of this triangle. There is one of 45 degrees too. So we want to get tan 60. Tan 60 is opposite, which is √3 over adjacent 1. So we use that to replace tan 60 here. That is root 3 over 1 equals to h over 55. So when you cross multiply, you have 1 times h to be h, and 55 times root 3 is 55 root 3 in meter. So we leave it in short form this way. And that, unlike the previous example where the height of the observer was not given, and hence we assume that the viewer's eye is on the same level ground as point P in that previous example. But for this one, we're giving the height of the observer. That means if the observer is observing the top of a tree, which is 20 meter high, this is the tree, which is 20 meter high, and this is the horizontal ground. This is the observer, who is 1.5. And when the observer has not looked at the top of anything, the high level is this. But for him to now view the top of this tree, we need to lift his eye, the gap between the original eye level and the new level. For him to see the top of the pole is the angle, and that is 25 degrees. So we have to find the height of the observer, meaning that this is the observer, the gap between the observer and the tree is horizontal distance. That's what we are giving. So which is this one, or you put it here. And of course, if you look at the shape down here, it's a rectangle, and opposite sides of a rectangle are equal. So you can put it there. Hence, for us to find the height of the tree, the height of the tree is the distance here from this horizontal ground to the top of the tree. Fortunately, if you can find this side of the height of the right angle triangle that we have here, at the end of the day, we'll add it with this. Look at this 1.5, opposite side of a rectangle. So if we're able to get the value of x there, we add it to 1.5 to get the entire height of the tree. So how do we do that? We check. We have this angle. The side facing is x, opposite. And this third side is adjacent, where we have 20. Nothing is said about hypotenuse. So what combines opposite and adjacent is tan. So we say tan 25 degree equals to x over 20. And if you check for tan 25, degree, ensure that your calculator is in degrees always. 4663 equals to x over 20, or use the tables. Here we are not asked to use the tables, and of course 25 is no special angles. Special angles are multiples of factors of 60. We have numbers such as, if you have 30, you have 45, you have 60, you have 90, all those ones that you can express as multiples of 30, then they are special angles. So for this one, we cross multiply. This one is seen as over 1. 1 times x is x, and 20 multiplies 0.4663. And we got the value of x to be 9.33 meter. So if x is 9.33 meter, then the height of the tree that we have to find, indicated by h here, equals to x plus 1.5, as can be seen from the diagram. X plus 1.5. So we simply come here and say h equals to the value of x is 9.33. Then we had 1.5 to get the height of the tree. 9.33 plus 1.5 should give us a 10.83 meter. 10.83 meters. So without wasting our time, we go to example 3.